A warm greetings to everyone. Welcome to today's Tech Talk presentation. The topic we are going to discuss is activity of daily living assessment through wireless sensor data from subject chemistry. Myself, Sai Parmeshwari. I am from Department of Computer Science and Engineering, AI and ML, from Section B. Today's topic is all about activity of daily living assessment that are performed through wireless sensor data. Without any further, let's start it. Here, I gave the content that we are going to discuss in this topic. We are going to discuss first wireless IoT sensors are and why are they used. The Internet of Things IoT is transferred over world in tremendous ways by enabling everyday objects to communicate wirelessly. We can automate data exchange and create new efficiencies that positively impact lives and organizations. Underlining the IoT is wireless sensor technology, which allows us to collect information about surroundings, environments over extended periods with little manual effort. Wireless sensors can be configured to measure a variety of variables from a temperature to vibration. Overall, there are many different types of wireless sensors available in the marketplace. Many wireless networks contain hundreds or sometimes thousands of wireless sensors. Already, these devices are used across a wide range of sectors, including retail, agriculture, urban planning, security, and supply chain management. Now, let's see what to do sensor do. These wireless sensors gather the data about local conditions and share findings with other powerful components or platforms. Further processing are typically disturbed across large geographical a- areas. They are performed to communicate with the central hubs, gateways, and servers. The advantage of this sensor are they require a low level of maintenance and a small amount of power to function. Sensors can support the IoT for needing a battery change or charge. Sensors are biggest question developers place is how to arrange wireless sensors in a field. Sensors or nodes must be distributed in such a way that supports the overchanging objects of the network developers. Now let's see how to wireless sensors network. The two most common arrangements for wireless sensors are the star and mesh topologies. The mesh topology describes networks in which sensors connect to as many other nearby nodes as possible. As a result, there will be less connectivity issue and less harm to network performance as data can take multiple paths to reach processing components. The star topology describes network in which every sensor connects directly to a central gateway or hub. These hubs take sensors information and transmit to other applications for processing. In these arrangements, nodes do not communicate directly with each other. Compared to mesh network, star shaped networks are more cost effective as fewer connections are required. However, it's hard to expand networks as any new sensors must connect central hubs which have capacity. Now, let's see how are wireless sensors communicated in the past. There are several wireless stands available that can support sensor networks until recently. Cellular technology was the most common used operations for wide areas networks connectivity. However, some up to disadvantages. These stands also fall under the traditional wireless solutions categories but have unquestioned advantages and disadvantages. Wireless is one of the most widely used wireless technologies today in business, offices, and homes. Zigbee is a wireless standard that realizes of mesh networking to support large number of nodes. Within a single network, Zigbee is best for wireless sensor networks that do not require much bandwidth. One disadvantage of Zigbee is that some sensors must also be on in order to share information for processing. As a result, Zigbee consumes more total energy than today's leading stands. Now, let's see what communicates stands government wireless sensors. All over traditional wireless stands are effective. A new class has emerged that much more effective for wireless sensor networks. Low power wide area networks LPWANs are growing as the go to technology for long range data transmission. LPWANs can support billions of sensors and will be used heavily for LOT applications. LPWANs offer several advantages over traditional stands. First, they consume less power from devices because they transmit information at a much lower bit rate. Sensor can survive several years on LPWANs, a single battery charge. LPWANs can also support sensors over vast geographic areas as data can be transmitted over long distance from a cost perceived deploying wireless sensors on LPWANs is less expensive compared to alternative methods because data rates are so low, hardware requires are less intense. There are several downsides to using LPWANs. LPWANs aren't well suited for application involving large data packets. Sensors network that need to transfer more data should use higher capacity cellular or short range Wi-Fi BLE and Zigbee network. Additionally, LPWANs use unlicensed ratio frequency which are harder to manage from a interface standpoint. Now let's see what are the leading LPWANs for wireless sensor today. The three primary LPWANs for wireless sensors are LoRa, SIGOF, and NB-IoT. LoRa, long range, is a widely accepted standard that uses a tip spectrum modulation scheme to transmit data over very long distance. LoRa is the foundation of low-band and publicly available layer specification and connects wireless sensors through gateways or LoRaWAN network providers. LoRaWAN has a higher bandwidth than SIGOF and can transmit data packets more effectively through noisier environments. With low band data is sent over hospital messages between gateways and network services. Services authenticate and decrypt data that is ultimately sent to end applications. Users can send messages directly to wireless sensors through LoRaWAN or Recofen devices. Consequently, C sensors enable no latency communication but consume more energy than the other classes of sensors. With all of these low-band sensor types, network developers must have proper gateway hardware to receive data and pass information along the services. Now let's see what makes an effective wireless sensor networks. There are several critical characteristics of well-designed wireless sensors network. First nodes should be easy to locate within a network. Sensor maintenance, such as replacing batteries and updating components, is much easier when developers know where to find all these devices. Second, sensor network should be able to withstand node failures without widespread speed distribution. Topology plays a big role in home networks handle connectivity issues. Those deploying wireless sensors networks must choose topologies that can withstand component failures. Third, network should be easier to scale. Developers must be able to grow their wireless sensors networks effectively without having to invest significant capa- capital to expand. Finally, it's important to consider power consumption when designing a network. The wireless sensor used should align with the data demands of the IoT applications. Otherwise, networks managers risk spending significant time and capital on ongoing maintenance and replacement. Now let's see how are wireless sensors used today. Already, there are many real-world experiment examples of how wireless sensor technologies is used today across a variety of industries and applications. The security sector has embraced wireless sensor technology in many ways. Without wireless sectors, organizations can monitor their premises, identify sub- suspicious activity, and track variable assessed. However, homeowners can also use wireless aid sectors to detect harmful gases in the air, such as carbon monoxide. Thank you.